Okay, this is Mr. Strickland, and in this lesson, I'm going to be explaining to you how to balance a chemical equation. Now, don't let that get you all bothered, because it really will involve counting and multiplying and very little else. Okay? So, this is the law that must be followed when balancing an equation, and that is the law of conservation of mass. What that law states is that the combined mass of the reactants, what goes into the equation, must equal the combined mass of the products, that which comes out. And that is because matter cannot be created nor destroyed, okay? It can only be rearranged to form new substances. So as I have written up here, in other words, the amount of an element that goes into a chemical reaction must equal the amount of the element that comes out of the reaction when the new compounds are formed. So just keep in mind, what goes in must come out in an equal amount. So now let's just take a look at how they tell you how many atoms are in a compound. Okay. What you see up here is the compound of water. Everyone knows H2O, but what you got to pay close attention to is that 2 means that there are 2 hydrogen atoms. So if you see a number to the right and below a letter, it's going to tell you how many atoms of that element are in the compound. You'll see that with the O, there is no number. And whenever there's no number, it is always assumed to be 1. So this is telling us that there is 1 oxygen for every 2 parts hydrogen. Okay? We don't have to memorize the elements. We just need to be looking for capital letters. Okay? So here's another example of a compound. And you'll see that it's got 3 different elements present because you see that there are 3 capital letters. In this compound of H2SO4, we've got 2 hydrogens, 1 sulfur, because yes, there is no number beside the S, and there are 4 oxygens. So we only pay attention to the numbers directly to the right of a letter. That'll tell you how many of them there are. So now we're going to add a number to the front. Okay, that's what's known as a coefficient. This is what we're going to be using to balance an equation that shows an unequal amount on the left and right hand side. You'll see that in a minute. Okay, now the 2 in front is kind of like saying there are 2 compounds of water. Okay, and what that 2 in the front, this big guy right here, it's going to multiply by the 2 hydrogens here and the 1 oxygen that is because the oxygen doesn't have a number beside it. So it's like the distributive property. We're going to say 2 times 2, that's going to give us 4 hydrogens, and then 2 times 1, which will give us 2 oxygens. So that 2 in the front, that's where the multiplication will come in, okay? So we counted how many. Now I'm showing you how you can multiply. Now let's look at an actual equation, okay? Now right here, I've got an equation that says we've got 2 parts of hydrogen that are going in along with 2 parts of oxygen. You'll see that little arrow. That's telling you what they form when they react with one another. And you'll see that they form H2O. Now, here's where we got to balance. The equation as it is written is incorrect, and it will be up to us to fix it. So this is how we do that. We're going to say, okay, we got 2 hydrogens going in, and then if we look over here, we've got 2 hydrogens coming out. So the hydrogens equal. 2 go in, 2 come out, they balance. However, you'll see that we've got 2 oxygens going in, but only 1 coming out. This violates the law of conservation of mass because as it appears right here, it's saying that we destroyed an atom of oxygen. We cannot do that. So it is going to be up to us to correct it. So first thing we did was we counted, okay, to see if we've got equal amounts of each element, okay? So this is how we're going to correct it. This is where the multiplication will come into play. You'll see that we had 2 hydrogens coming in, or 2 oxygens coming in, but only 1 oxygen coming out. In order to correct and make the oxygens equal, you do this. You say, well, if I got 1 here but 2 there, what do I multiply 1 by to get 2? And that's where this 2 in the front comes in. If we put this 2 in the front, it's going to now say 2 times the 1 oxygen to give us an equal amount of oxygens. However, when we place this 2 in the front of H2O, it will also multiply by the 2 to the right of the H. So it's going to be saying we have 2 times the 2 hydrogens giving us 4. So now we've got 4 hydrogens on the right, but only 2 on the left. So we created matter. This happens. You're going to make errors as you go, but that's just the name of the game. Okay? So once we place that 2 and realize we have more hydrogens on one side, that's when we're going to go back to the right-hand side. And we're going to place a 2 in front of the H2 that was on the left-hand side. Now, check this out. What I'm going to see is 2 times 2 H's is going to give me 4 hydrogens on each side. Because we got the 2 times the 2 here, giving us 4. 2 times the 2 on the right, giving us 4. So we got 4 hydrogens on each side. Boom, a balance. Right here, we got the 2 below. That represents 2 oxygens going in. And then we've got, remember, this 2 multiplies by the 1 that would have been beside the oxygen. So the 2 times the 1 oxygen gives us 2 oxygens. So we've got 4 hydrogens going in, and 2 times 2 giving us 4 hydrogens coming out, 2 oxygens going in, and 2 times the 1 giving us 2 oxygens coming out. We have balanced the chemical equation. Matter has neither been created nor destroyed. It is completely equal.